So, a very warm welcome everybody to Quickly Testing Legacy Code. I'm Clare Macrae, Clare Macrae UK on Twitter. I've been paid to program for a living for just over 30 years now, 31 years. For the last 20 of those I've been programming in C++, or Qt or Qt, depending on how you're used to pronouncing it. So I have a lot of experience of working with legacy code in the same organisation for that time. So let's start with a bit of an introduction. About 18 months ago, I was a product owner. I sort of stepped out of programming for a little while, and I saw this tweet from one of my legacy code and programming heroes, Llewellyn Falco, asking for help converting a library called Approval Tests, which I knew nothing about, to work with the Google test framework in C++. And I very tentatively said, well, tell me a little bit more. And so we spoke and we worked together, and over 18 months of remote pairing, a few times a month, it's very much a hobby activity, or has been very much a spare time activity. I've now felt I've learnt so much from that process that I'm really keen to be able to come along to conferences and try and share a lot of useful practical knowledge I've gained from that, and I think is not super well known in the C++ community. So that's my goal, to share techniques for easier testing in challenging scenarios. Maybe legacy code, maybe new code, doesn't really matter. But let's talk about legacy code for a few minutes and what I mean by that. I love this cartoon. Legacy, looks easy, yep, should be done in half an hour, I reckon. One little piece of string, how hard can it be? But what does legacy code mean? It means different things to different people. The most famous definition, I think, is Michael Feathers and code without unit tests. J.B. Rainsberger talks about profitable code that we feel afraid to change. Until recently, I worked for a non-profit organisation, so that profitable code didn't sit very easily with me. Kate talks about any code that you want to change but are afraid to. I really like that one, but in a sense, it doesn't really matter. Any of those is great, they're all valid. And if you've worked with legacy code, maybe you're familiar with this kind of scenario. You've inherited some code. It's valuable to you. You need to change it. You need to maybe add a feature, maybe you need to fix a bug. And so the cycle goes like this. I need to change the code. But there's no tests. So I'm afraid I need the safety net, the safety harness of having tests, but the code wasn't designed for testing. And so in order to add tests, I need to refactor the code. But everybody knows these days you need the safety net of tests in order to safely do the refactoring. You can't refactor without tests, you're back to square one. And that's the cycle that I'm talking about in this talk and trying to share knowledge to help break out of that cycle. But the focus of the talk is going to be on that right-hand side. I've got no tests, my code wasn't designed for testing. What first steps can I take to start adding tests? I do make a couple of assumptions, though, to try and focus the talk. And the first of those is that you understand the value of automated testing. I'm guessing you wouldn't be sitting here and giving up an hour of your Saturday if you didn't already understand that value. But for anyone not convinced, that's a whole separate talk. I also would like to ask you to suspend any concern about different types of unit tests. There's lots of good advice about writing small unit tests, testing small components of code, and then versus integration tests versus regression tests. At this point, I'm going to say, in the scenario that I'm talking about, any tests are good, don't worry about them being perfect tests. You want to start building in that sort of safety net. So you've got this inherited code, and that has to be question number one. Are there any tests at all? And if, part one of that scenario, there are no tests, then step away from the keyboard, step away from the talk, the video, go and find out about adding tests. And 20 years ago at work, we had a home-written, a sort of homegrown testing framework, but over time, we migrated to Google Tests as it happened. So whatever test framework you use, definitely pick an existing test framework rather than writing your own. In C++, probably the most popular ones are Google's own test framework. That's the link there. Or much more recently, one called Catch. Now, the current version is now Catch 2, written originally by Phil Nash, but now developed by others as well. They're both fantastic. I've used both, really, really recommend both. Catch is a single header test framework, so you don't need to change your build system. You can just copy the file in. Google Test, on the other hand, you need to be confident in your build system of adding that dependency. Whichever one you pick, then you need to start getting familiar with writing tests as you develop. And if that's a new topic to you, then this is a great book, Modern C++ Development, Modern C++ Programming with Test-Driven Development. When writing this talk, I went back and had another look at this book, and it has an entire chapter on working with legacy code, which is very good. But the whole premise of that chapter is you have to modify the code, change the design of the code in order to add tests. And in a lot of ways, this talk is a precursor to that, so trying to help you write initial tests with the absolute minimum of changes to the code that you've inherited. A very good book, though. In a different world, you've looked at your existing tests, and there are some. Though that's great. The people who worked on the code previously have written tests. Does the tests are passing? No failures. It's all green. That's good. Can you just start refactoring the code? Well, I would recommend that you put a little bit of time into exploring those tests and working out how good they are. So evaluating the tests, testing the tests, if you like. Big caveat for that, though, depending on the volume of code you've inherited, is try and focus on the area that you need to change. If you can narrow down the area that your feature is going to be added to, it can be tempting to try and understand everything, and that's a great way to lose your productivity and get really bogged down. So one way to evaluate the tests that you've got is to see how much of the code of interest they're actually executing. And a well-known technique for that is measuring the code coverage. So measuring how much of the library code or the application code that you're going to be maintaining is covered by tests. There's a big note of caution with this, though. Just because a line of code is executed by a test doesn't mean to say that the results of that code actually are tested. I'll talk later about dealing with that, but with that caveat aside, a couple of different techniques for understanding code coverage. One I learnt from a former colleague years ago is to put in, edit and put breakpoints, so read your code and put breakpoints in your debugger, perhaps in every function, perhaps in every if statement, every if then else kind of thing, and then execute the tests in the debugger, and every time you hit a breakpoint, you turn off the breakpoint, you delete the breakpoint. Then when the test has finished running, all the remaining breakpoints, they tell you unexecuted code. Okay, it's a bit time consuming, but you don't need any special tools to run it, and it can be really useful. The alternative is to use a tool that has been created to measure code coverage. And don't worry about the detail. I'm not expecting you to be able to read this slide, but this shows a programming exercise called the Gilded Rose Carter, popularised by Emily Bache, B-A-C-H-E. And this is using a free add-on to Visual Studio called Open CPP Coverage. And the green lines here say that in running a test, every single line was executed, and so at the bottom in the small print it says code coverage 100% for this really horrible nested function. So that's good, right? Perfect tests. But the line that's highlighted in red is an if statement with if A or B effectively. So there's two conditions, each of which can be true or false. And this tool, this free tool, Open CPP Coverage, just says that line 10 was touched. With a different tool, a commercial tool called Bullseye Coverage, line 10 is presented differently here. So line 10 is broken down to 10A, 10B and 10C. So 10B says the little t and the little f, that condition was covered by the tests with both true and false. And 10C says that the second condition was covered with true and false. 10A says that the combined condition, the two capitals T and F, are covered with true and false as well. So with this kind of technique, you get a much better sense of how much of your logic, your conditionals are covered by the code coverage tool. Now, again, I'm not saying that it's worthwhile striving for 100% coverage. I'm encouraging you to be aware when inheriting new code and evaluating the tests. You might decide that the case is not covered further down. There's some red arrows say that only true was covered and not false. Maybe the cases that are not covered are complete corner cases, unrealistic exception cases, and you don't want to spend time adding tests. Or maybe you spot some really core path through your code that you want to add tests for, but being aware can be really useful. Another technique, once you know that code is covered, is to use something called mutation testing. This is really fun. You set out to sabotage the code, basically, and see if the tests can tell. Of course, this is based on the assumption that your code is in version control, so once you've sabotaged it, you can easily revert back to the previous state. So here, you're testing the tests, you're making small changes to the code, rerunning the tests. And this is the opposite way round from how unit tests normally work. So the green situation, the fail, the smiling case there is your test suite failed, therefore it detected at least one of the changes you made, or maybe you only make one change at a time. If the tests pass, that says they weren't able to detect your mutation, your sabotage. For reference, I will make the slides available at the end, so you'll be able to pick up the links. I'll tweet them in a couple of days' time. You can either do this by hand, thinking about the kinds of changes a future developer or your future self might make on the code, or there are tools available. A recent episode of CPPP Cast, episode 198, specifically talked about a tool, Mull, and the show notes for that list also the awesome mutation testing link at the bottom, which has covers many different languages with really, really useful tools. So commend that to you. So what if you discover that you're still not ready to start maintaining the code? So for whatever reason, you do need more test coverage in the area that you're going to be working on, but you've seen enough about the code to know now that it's too complicated to set up unit tests without unsafe refactoring. That's what the bulk of the rest of this talk is about, that situation. So let's talk about testing legacy code. And people who work a lot with legacy code and are really practiced in refactoring and things like that talk about locking down the current behaviour. That's a really, really key phrase. So it's don't know anything about the current behaviour, don't want to start reasoning about the behaviour yet, but I want a way to make sure that if I change the behaviour, I find it out. Get feedback soon. So locking it down, making sure that you can detect unwanted changes in program state, program behaviour. So I touched on this already, but writing tests for legacy code can be really time consuming. But a really important aspect of that is if you're looking at a small part of the code and you don't know what the intended behaviour is, you might write a test and capture the current behaviour, but it might not actually be an executed path of the program. It might be dead code, but your act of writing a test for it makes it harder for your future self or a future maintainer to change that code. So what about another way? There's a technique called golden master testing, which I learned about at a meetup maybe 10 years ago or something like that. It's a very simple idea. The idea with golden master testing is that you take some input that you know is feasible, reasonable input into your program, the body of code that you're testing. You pass that input in, and you then save the output from the program. And you call that output the golden master. And that's what you capture, that's what you save in version control. You save the inputs, the way to run the program, and the output. Now, you might need to modify the program to write the output in a meaningful way. But that's your golden master. Capture that in version control. And then over time, as you're updating the code, you keep putting the same input through the program. And in the case where you were refactoring and not intending to change the behaviour of the code, if the output is the same, that means your test has passed. And if the output changed, you've probably made a mistake in the refactoring. You want to fix the edit that you made, or probably revert it in source control and come back and try a different way. So I implemented that sort of idea on a large body of C++ code where I was working at the time, and it was a great way to start testing where there weren't tests already. But how easy it is to use is really important, and in the system I set up, it was not easy to capture the existing output. It wasn't super easy to get stable output because it was writing out a very large volume of text. And I actually found out recently that someone who didn't understand the huge volume of text that I was writing out, didn't understand the small bits of information that mattered, they changed the output stream operator for one of the objects I was printing and stopped printing out the key information that the test existed. So that test has been passing for 5 or 6 years, not doing anything useful. And how easy it is to review the differences is quite important as well. If you write out too much information, it can be hard to do that. It's also really important to make sure that what you set up is robust enough that people don't accidentally overwrite the golden master with what should have been a failing test but now becomes your new right answer. And the way that we set up to overwrite, when we wanted the output to change and we wanted to overwrite the master, you had to edit the source code to say now overwrite the expected file, and if that was forgotten and committed, then every future test would update the expected output. So I'm now going to move on to talking about approval tests, and now we're talking about the quickly testing aspect of the talk's title. And there's a technique called approval tests, created and popularised by Llewellyn Falco, who I mentioned back at the start of the talk. And at its simplest form, it's a powerful and flexible implementation of the Golden Master technique that I've been talking about. And for some years, it's been implemented in a range of different languages. What's changed is, over the last 18 months now, there's a very powerful implementation in C++. And that library that I'm talking about, in the GitHub, it's called approvaltest.cpp, which I've learned is a bit of a confusing name because it sounds like a source file, but it's a library meant for testing approval tests in C++, but because of the naming convention that they've used for all of the different language implementations, it sounds like it's a file name. So maybe I think it might be good to start talking about approval tests for C++. That might be less ambiguous and clearer. It's cross-platform, works on Windows, Linux, and Mac. It's for both testing legacy and greenfield systems. The GitHub URL comes later. It is header only, which makes it really convenient to download and use, much like Catch. It's open source and Apache 2.0, so I think most organizations would be able to copy the current version into their source code if they wanted. And it works with a range of different testing frameworks, most notably Catch and Google Test. I'm going to talk now through a few slides, trying to give you a sense of how to use it. In the interest of time, I won't go through all of the details. There's more details in the video of my talk at meeting at C++ on C in February earlier this year. And there's more information in the slides as well if you want to download those later on. The easiest way, if you want to just start playing, is there is an approval test.cpp starter project, and you can go to the download link on GitHub and download the zip file. You don't even need to clone it or anything like that. Download the zip file. And there are CMake files included, and Visual Studio 2017 solution as well, which of course you can open in newer versions of Visual Studio too. So if you want to start experimenting, that's a good way. Alternatively, you could download the header file yourself. And for that, you would go to approval test.cpp on GitHub. We're up to 13 releases now. You see the red box in the middle. And when you click on that link, you go to, at the top of the page is the latest release. This release had quite a range of features, so you would scroll down until you get to the header file there that's shown in red, and you would download that file. Okay, so why am I telling you that? That's trivial. I'd like to talk about the version number that's in the file name, because it might be tempting to download that file, put it in with that file name in your version control system, but then if you've got 30 test files, all of which hash include a file with a version name, that's going to be really annoying when you update to a newer version. So you could save the file without the version number. The way that the starter project uses, the starter project I just mentioned, is to have a single file without the version number in the file name, and then that hash includes the file with the version number in the file name. So that adds a level of indirection. So in the unlikely event that you change to a different version of the header and you're seeing something odd, like this hasn't happened yet, but gives you the options very quickly, switch between versions. It's not a big deal, but I just wanted to point it out as something to bear in mind. I'm going to talk now through some examples of using approvals with catch. Using it with Google Test is very similar, and we've got pretty good documentation now for both of these situations. So in the interest of time, I've picked just catch for now to talk through. The first thing you need to do in setting it up is to make sure that you've got a main function, a main program that tells approval tests how to recognize the unit tests in the framework that you're using. Because as you'll see, approval test really depends on knowing the name of the source code where the test is compiled and what the actual name of the test is. These are standard concepts in modern testing systems. And so by hash defining approvals underscore catch in our main, and then including the approval tests header named to your liking, that's all you need to do as an absolute minimum to set up your main. Now, catch actually works fine if you don't provide a main. No, that's the wrong way around. Google Test works fine if you don't provide a main. It provides its own. If you forget to do that, we've got a really nice help message, thinking back to the difference between error message and help message. That tweet that Kate mentioned this morning specifically drove us to add, if you forget to put this sort of thing in your main, a really specific message about exactly what you need to do in your code to fix this problem. So, yay for that tweet. This is what a pure catch2 test looks like. This is no approvals test on this slide at all. You include the catch header. All your tests begin with test underscore case, normally, and then you give your test a name. And in catch, your names of your tests are strings. They can have spaces in. They don't have to be. They're not symbols that are compiled in C++. And then catch has this require macro for the thing that you're testing. So you're requiring that 1 + 1 = 2 is true. And you can have as many require statements as you like in your tests. Moving on now to an approvals test in catch. Exactly the same hash include catch as before, but now you need to include approval test header as well. And you'd have the same test line as the test name, same test case, same kind of idea with the test name. But the approvals vocabulary is that you're verifying something, you're verifying the state of some object. So approvals verify. And you might be thinking that's a really, really strange idea for a test, because when you write tests, you state the expected output. Tests, surely they always have two things. So this is what I'm doing, and this is what I want the result to be. And that's part of what's time-consuming about writing tests. So approvals doesn't work like that. Approvals says it's going to capture the current state of that totally artificial fixed string for the sake of demo. And so let's look at how that works. So the first time I run this, it's a brand new test. It's never been run before. I wanted to point out the name of the test is test fixed input, and the name of the source file is test02.cpp. These will be helpful in the next slide. So the first thing that happens is I'm running this in Visual Studio. Visual Studio says that the test fixed input fails. And the failure message was there was an unexpected exception thrown, approval file not found. And a differencing tool opens up. On the next slide, I zoom into the differencing tool. And I want to talk about the text that's highlighted in red right now. So on the left-hand side, we see test02.testfixedinput.receive.txt. So this is a Windows graphical differencing tool, and it's showing me a file called received, test source file name.testname.receive.txt, and those are the 3 lines from my static text that I'm testing. And on the right-hand side, same base, test02.testfixedinput.approved.txt. And this vocabulary is really important. It's really key to understanding approval tests. So the approved is what has already been approved. It's already, you have stated, you have authorized this as the right output. We've never run this test before, so there is no right output, and that's why this file is empty on the right-hand side. On the left-hand side is what you're currently getting, the received. And I've put that at the top, the expected and approved. That vocabulary is really important. I think a lot of test frameworks talk about expected is what the framework expected or what your test expected, and actual is what you get when you ran the test. Llewellyn chose approved on the right-hand side, which fits with the library name approval tests, and then received. And he's used that vocabulary consistently in other languages, and so we're using it consistently in the C++ implementation as well. So if we're happy with this output, which I am for the sake of demonstration purposes, then whatever differencing tool opened up, you want to use the feature in the differencing tool that, okay, I'm not even going to, I've got the presenter's view here, so the scale is completely different. So what you would do is you would click on the blue arrow there, which is Araxis Merge's little symbol for copy from left to right. And then now what happens is the text is the same on the right-hand side as the left, but we haven't yet saved the file. So we need to save the file by clicking on the Saved button. And now the file is saved, and now we close the differencing tool. And now we have, that's it, we have approved the output of that file, of that test. When we rerun the test, approvals now says the test file passed, and Visual Studio passes that on to us. So once we have done that, we commit our new test and the approved file to version control. And from that point on, approvals only shows the differencing tool if there's a change in behaviour. So its default is to be silent. So are there any questions at this point? Because that is really, really fundamental to how this works. I talk about it in some more detail shortly. Okay. So at its core, it's basically a really, really convenient form of Golden Master. It allows you to see the differences really easily. It does depend on the objects that you're testing being stringified. And when I first spoke about this, I talked about the output stream operator, output insertion stream operator being a fundamental requirement. But actually, that's not true. It provides multiple different ways to create string representations, ideally of the subset of information that you're interested in from the thing that you're testing. So once I've added a few more files, a few more tests, a few more test cases, my test directory will look something like this. So the lines in grey are the source code lines, and then we've got some approved files. You can see based with the file name starting the same name as the source code name. And mostly I've only got approved files. At the bottom I've got a received file. What happens there is if your test passes, approvals deletes the received file because it's clutter, you don't need to see it, but if the test fails, it leaves it there so you can compare it with the approved. Over time, though, having all of those files in one directory can get really quite cluttered. So you can add these lines in yellow to your main. You can call a function approvals, use approvals subdirectory. The text in quotes, the string in quotes approval test is actually the default value, but I've included it in this call for sort of explanation purposes. You do need to hold on to the return value. So the pattern with most of the customization in approval tests is it returns an object that contains information about the previous state. And when that object is destroyed, it reverts the library back to its previous state. So you can, for one test only, store files in a particular subdirectory and then revert back to the default behaviour. So it is important that you hold on to the returned object. If you do that, then your directory structure becomes source code at the top level and then your approved and received files in a subdirectory. So I'm going to delve a little deeper into that now. And when I first spoke about this library in February, my motivation for doing that was we didn't have any user documentation at all. And at the time, it was hard to see how we could make enough time to write documentation. So giving the talk became the documentation. We have got now into a regular pattern as we add new features of documenting them. So we now have a user guide, which is linked from the home page, and this is the table of contents from the user guide. I'm going to pick out just a few links from that I think are useful at this stage. So about a third of the way down, we've got using approval tests with Catch and using approval tests with Google Tests. So you can find more information there. In the section writing tests, the toString link is really important. So in this talk, I've only got time to show really basic usage of it, but how you express the information, the output from your test, from the process that you're locking down with approval tests, how you represent that information is crucial to how easy it is to understand the test and how safe it is for someone maintaining the code in future to understand the change in behaviour. So captured in that toString page is a lot of really valuable information based on experience of someone using this library over many years, over many organisations. And then lastly here, the features link. As we add new features, we don't always know where's the right place to document them. So features is a sort of bit of an odd rag bag of recently added functionality. Eventually that documentation will be moved, but we will keep the link to each new feature there. And then right at the very bottom, there's troubleshooting, what you need to do to support a new test framework, which is very little, and should you wish to contribute to approval tests as well. Spoiler, the shortcut is we'd love to pair with people who want to contribute. So our default isn't submit a pull request, it's talk to us about what this can't do and what you need it to do, and we'll pair with you and try and help you implement it together. That way we learn more about uses of the library as well. I mentioned a few tools as I go along, and right at the end there's a slide of references. So how does this help with legacy code? The next few slides, they're quite abstract, but I'm going to try and explain them anyway. So the canonical pattern for using this with legacy code is as much as possible to wrap up the operation or operations you're testing into a single function or method that returns something that represents the results of the operation that you're testing that you can then pass into approvals verify. It might be a custom you might need to add some extra information about how to represent the result as a string. And I know that this is a bit of a source of frustration to Llewellyn because he's seen this pattern and put it into use many times, but he actually worked with me several times when I was saying, but my operation, I've got to do this setup and then that setup and then this and then create one of those and then save one of those. And so I had like 8 lines of code and then my verify. And it took me a while to work out that it really was worthwhile hiding all of that setup that I understood, because in that case I understood the code I was testing, behind that simple method that returns a thing that you can verify. Because at that point then it becomes really easy to use these approval tests with lots of different types of data. So then you end up with a sort of reusable framework, small bit of reusable framework for the thing that you're working on. An example of how you might implement this, obviously there can be no detail, this is sort of representing some arbitrary thing in your code, but say you've got a class, which I'm calling legacy thing now, you could write an output stream operator that says how to represent that as your legacy thing as text. And your do legacy operation would hide all of the implementation details of how you do that setup. It turns out via that to string page on the user guide that you don't have to use an output stream operator, and that's great for getting started, but as I said, it subjects you to the whims of future developers changing the format. So you can use simple functions or you can use lambdas. It's much more flexible. So I'm going to talk briefly about some of the features of this framework. Because when you look at it, it's actually a very small volume of code, not a very large interface at all, but it turns out to be really powerful. So it gives you things like consistency of naming, regardless of the test framework you use, the platform that you're running the code on. And by version controlling the approved files, of course, that gives you consistency. You need that to be able to run it on different machines. It gives you consistency over operating systems. As a result of experience, it's very opinionated that text files are equivalent even if their line endings are different, which was really hard for me to accept at first, but it means it doesn't matter how your version control system is set up. You can be checking out the code on multiple different platforms and not worry about what the line endings are. It's consistent over languages as well. I talked about that received and approved thing earlier. Occasionally we've gone to implement features like there's something called a front-loaded reporter, which I found quite confusing, but we opted for consistency with implementation of all of the other languages so that someone who gets used to using this framework in one language is comfortable switching to different languages. It's really quick to write tests. So I showed you a trivial example where I was verifying one thing, but there's multiple overloads of approvals verify all, where you pass in a container or a begin and an end, and here's a lambda version. So you can increase your test coverage really quite quickly. There's also a verify all combinations in which you can pass in any number of containers, and so here the strings that are being passed in are hello and world, and then there is a vector of ints being passed in, which is the numbers 1, 2, and 3. And this is testing concatenation. So the output that came from that lambda is showing that with the inputs hello and 1, the outputs are hello space 1. So it's a trivial example, but this is trying to convey the value of, by formatting your text so that it shows the input data that you're feeding into the thing that you're testing and the output, makes it much easier for anyone inspecting a test failure in future to understand what's changed and what's going on. In terms of customizability, it has a fantastic feature called reporters. Mostly in this talk, I'm going to gloss over the implementation, customizability layers in the interest of time, but the reporters, they're really important. Under the hood, essentially what's happening is when you say approvals verify, approvals is converting that object to a string representation, saving that to a file, and then saying ignoring line endings. This is out of the box default behaviour. Ignoring line endings is the contents of the received file I just wrote and the approved file identical. And if not, it calls on a reporter to show the difference. So when I showed you Araxis merge running, that was its Windows Araxis merge reporter. And it knows about a dozen, maybe 24 different differencing tools that are common tools on Windows, Linux and Mac. Coverage is less good on Linux than the other two. So it has a list of those and it loops through until it finds one that it sees installed on the program, on the computer that the tests are running on, and then it pops up that differencing tool. But this is highly customizable. So you could, for example, use another reporter, which is auto-approve on failure reporter. And that says, I don't want to have to manually approve in a differencing tool 500 files, 500 tests that I know I've deliberately changed the behavior of the program. I want to update the output. And then I will review the differences in my version control system later and decide whether to accept them or not. So this reporter's customization is really, really powerful. You can specify a custom reporter for an individual test like this, so all of the methods I've been showing you. You can pass in a reporter. You can, in a main, you can call approvals use as default reporter. And as before, you would need to hold on to the return result. So here, I had another differencing tool installed that approvals was picking up in preference to Araxis merge. But to create the screenshots I showed you earlier, I wanted to run Araxis merge. So that's how I told it, trust me, that's the one I want to use. Or you can give a path as well to a tool if you've got a tool that it doesn't even know about. On continuous integration systems, you would want to make sure it didn't show up a differencing tool. You wouldn't want to block the build, and there's multiple different ways of doing that. So this thing that I've been talking about know about the tools that are installed, commonly used tools, and try to use those. This was a thing I wasn't aware of called convention over configuration. I actually think it applies to much more than just this library or just testing tools. It's saying try and make fewer decisions for the developers or the users of your software by default. Try and do a sensible thing from the outset. And if that doesn't work, tell people what to do, but only require the users to specify behavior if they want an unusual behavior. I think it's a really, really powerful principle. So at this point, I'm often asked, well, that's great if your output is stable, but I'm testing something that writes out, I don't know, object addresses, dates and times, something like that. How can I deal with that? And a common answer will be introduce an abstraction for date and time and insert that into your code and pass it all the way down to the thing that does the logging. And that's great if you're comfortable making changes to the code at that point, but that's often not the case. Or maybe you implement a customized comparison function that recognizes that one line has a date and time in, and you have to decide what to do if the other line doesn't. So the approval test's approach to that is to do something completely different, which I think is a brilliant insight. It's to say, don't do any of those things. After the system has written out the file, read it back in and strip out the unstable information from the log file, resave the log file. So in the example I just showed you, on the left-hand side is the pictorial representation of our log file, and So you allow your system to write that out. You then have your test, read that log file in, and perhaps with a regular expression or something like that, you substitute some fixed string to represent the unstable data. And then what is in the approved file and the received file initially at the end no longer has changing data. This is one specific example of that general idea that you can take control of the data that your program has written out and change it in a way to make it stable for testing. There isn't time to go into the detail of this, but the class of interest here would be the approval writer interface, and you'd be looking at providing a custom implementation of its write method that allows your code to do the write and then reads the file back in and modifies it. So I think the thing for me is I've mentioned this is a flexible library and it's a powerful library, but in a lot of ways the power is non-obvious, and that can be the hard thing about spotting ways to use it. But it's way, way, way more powerful than Golden Master. So your reporter could, for example, if you've got lots of numeric data, how would somebody decide whether a change in the content of the file is valid or not? You could additionally convert that data to some charting, run it through some charting program or something like that, so that as well as someone evaluating a load of text, which is hard to understand, you also give them a picture to understand, and maybe you show it to your domain expert or something like that and have them say, is this good enough? Do you care or not? So there's really, really powerful functionality and flexibility built in there. I'm going to spin very, very quickly through an application of this. So a little bit of background. Until recently, I worked at an organisation, Cambridge Crystallographic Data Centre, and that's a database of over 1 million crystal structures, so 3D positions of atoms, shapes of crystals in medicines and things like that. And since I first wrote in 2000, the crystal structure visualization program Mercury, we always represented atoms as spheres. So we've got some larger spheres in the middle, some smaller ones around the edge. Those are atoms joined by bonds. And I was recently asked to add another way to represent atoms in this program as polyhedra. So an example of a crystal sugar. Inside that sugar crystal, there's a molecule, sucrose. You can see the atoms and bonds there. But in practice, it's a very, very large repeating network. That's the application that we're talking about, the sort of scientific area. So I was coming up to giving the C++ on C talk, and I was interested to see if I could use approval tests for something other than text. And so what I was aiming for, Qt is the GUI framework that we were using, and Qt has a class QImage to represent an image. So I wanted to see if I could use approval tests to approve images. The details of this are obviously very specific to that code, so not something useful to share, but I did want to mention that the lowest level of approval tests is this file approver verify. And so you've got control over how the files are named, you've got control over how files are written, and I needed to make sure they were written as PNG files for easy visualization, and you've got control over how differences are reported. So here's an example. You might be able to see some little bits of red down there, the little differences. So this is a screenshot from when I changed the implementation of the display of polyhedra. And I was fully confident that the change I was making to actually I was changing my test to speed it up, fully confident this wasn't going to change the pictorial results. But approval tests showed me that there were some really weird edge effects. I never did get to the bottom of that. The intention was that the change I made should not have affected the behaviour of the program. So that told me something useful about the 3D library. When I was remote desktoping into work, I found that running these, basically what I was doing was taking 100, 200 crystal structures and drawing them in this new display style. And as I was adding new features to the display, I was wanting to check that the that the display was improving with each change. What I found when I was logged directly into my computer at work, I started getting flickering failures. And actually at this point I was using Araxis merge to compare images, and there's no way in Araxis merge you can understand what the difference is. So I tried out Beyond Compare version 4 instead. Don't worry, I will zoom in successively on slides. But this said there were 4 important pixels differing in this image. And as I zoom in, it's still hard to see. Maybe zoom in a bit more. You might see a little bit of red there. Zoom in one more time. And there's a little panel on the left-hand side, which again I'll zoom in on. And when I hover over one of those pixels, it says red value was 42 on one pixel and 43 on the other. And approval test was treating that as a difference. The files weren't identical. So as a result of that experience, we added a way to provide a custom comparator within C++ approval tests. So I wanted to say if all the pixels in an image are identical or differ by no more than one value out of 255, I wanted to treat that as equivalent. Llewellyn, with his very pragmatic perspective, said, but you don't need to do that. You can read all the files back in and rewrite all of the RGB values as even numbers, and that will get rid of any differences by 1, which would have been a lot less work, but the graphics programmer and me was saying, no, I don't want to do that, I want to see the original files. So both choices would have been valid. So approval comparator is a new customization for that. And I ended up with some function, compare QImage, ignoring tiny differences. I'm going to gloss over this detail in the interest of time. But so the important thing with this, I guess, when you're working with legacy code, it's often brittle. It can be. It can often be. This was new code. I wasn't expecting any differences to appear. But it's only when you write the tests that you can see the changes, that you make these subtle changes visible. Having seen them, you then need to decide whether any of those changes matters or not, and even if they matter, whether you're going to do anything about them or not. And that comes down to the knowledge of the programmers and the domain experts where you work. But this allows you to see those changes, and that fast feedback cycle could make for a much more efficient development. So looking back, it was really valuable using that graphics example. I learned a lot about that code, but I learned a lot about approval tests, and we improved it as well. So there's a range of customization points, which I have touched on, and there'll be more documentation on these coming soon on GitHub. So just on to the last sections now. So here are the links for the differencing tools that I mentioned and the code coverage tools. When you get to the happy stage that you're comfortable with the test coverage, now you want to start actually improving the code. The next few slides are a few really useful resources. So Kate's Pluralsight video, beautiful C++, updating legacy code. It's really good. Jonathan Bocara has recently published a book, The Legacy Code Programmer's Toolbox. If in doubt about legacy code, I recommend reading that. It will completely change your mindset about working with legacy code. And this is about when you're working on code that you don't understand and you can't even begin to see how to refactor it. The link is at the bottom of the screen. It's a video by Llewellyn Falco and Woody Zorn. This is how I first encountered Llewellyn Falco's work. It's called 2 Minutes to Better Code, but it's actually a 2-hour video. I showed it at work a few years ago in 3 sections with a small team that we were really struggling with code. We basically pulled this video apart over 3 days and then stuck really carefully to the practices it recommends, and the code was utterly transformed. Adam Thornhill has written 2 fabulous books based on understanding the history of large code bases from their version control system. But actually it's really more about exploring team interactions and things like that. The brilliant title, Your Code as a Crime Scene, was his original book, and he's since written Software Design X-Rays. Both really good books. So a very quick summary. The first thing I want to say, if you are adopting legacy code, is you can do it. There are really useful resources now. People are writing about some proven techniques. So start by evaluating the current tests, improve the coverage with Golden Master, and of course I recommend approval tests as one way to do that, whatever language you're working in. And it's useful even for non-text types. A quick reminder that the key methods are verify, verify all, and verify all combinations. So I've talked about this purely in terms of as perhaps I might have made it sound like it's an alternative to unit tests. It doesn't have to be. So in an ideal world, you might create your Golden Master, refactor the code and add unit tests until the point where you actually don't need the approval tests anymore, and you could archive the approval tests. Or maybe you decide that's too expensive and you're happy with the convenience that approval test gives you and you keep some sort of balance. You can mix in unit tests and approval tests. So thank you very much for your attention, and in the tiny amount of time left, I'm happy to answer. Is there any time left for questions? Okay, super. Thank you.
Thank you, that was really excellent. So I'm currently working with quite a large legacy code base. And one of the interesting things it does while it's running through really rather large functions is it just prints what it's doing to std out, or if it has some error that it encounters, it prints std error. So I was just wondering if approval test is able to capture that in order to put in its reference files, or any other tools that you might be aware of.
That's interesting. I guess you would need to, you can either in your program control where standard output goes to, or you could, perhaps you might use the Python version of approval test and run your program via a system call or something like that and save the output. I think that people who've used approval tests would probably say, take any reasonable measure that you can, so put all notions of, you know, what's clean code, what's perfect, if you need to make data public temporarily or add an access, whatever reasonable method you can do to start locking down the behaviour, and then you can improve it later on. So I don't think this immediately would provide something like that, but if you can control where the output stream would go, you could send it to a received file and start building it in that way.
Okay, super, thanks.
Thank you for the talk. I just want to ask, can we use C++11 to use approval test? Or?
Thank you. I should have said that. This supports C++11 and above. So yes, you can, definitely. Okay, thank you very much. Can I just close with one thing? So I mentioned that until recently I worked on that crystal structure visualization software. I'm taking a break right now to do some more work on approval tests and improve its documentation. So I would encourage you, if you try it out, if you get stuck with it in any way, if you can think of any ways that we could help you use it in your environment, I'd really appreciate it if you got in touch, because there's an opportunity to improve it for other people. So the offer is there, and encourage you to take advantage of it. Thank you very much.